Hello everyone, today we're going to be talking about head loss and piping systems. So first off, what is head loss? Head loss is essentially the energy loss due to frictional losses and viscosity. This is really important in fluid mechanics to calculate pressure difference in piping systems and also pump sizing and selection, such as when calculating the MPSHA. There are two different types of head loss. The first type is HL major, which is mainly due to friction loss. The second type is HL minor, which is due to valves, fittings, and bends. Altogether, the total head loss is equal to HL major plus HL minor. First, we'll talk about major head loss. Major head loss is calculated by using the formula on the screen, which is a friction factor times the length of the pipe over the diameter and then multiplied by the velocity squared over 2 times the gravitational constant. Now you might be wondering what F, the frictional factor, is. Well, the frictional factor is a relationship between the Reynolds number and the relative roughness, which can be calculated using the Moody chart. Once again, the friction factor for your piping system can be calculated using the Moody chart shown in the picture by using the Reynolds number, which is measured on the x-axis, and the relative roughness, which is measured on the far y-axis. You'll be able to calculate the friction factor. Minor head loss, on the other hand, is calculated using a different formula. HL minor is equal to the loss coefficient times velocity squared over 2 times the gravitational constant. The loss coefficient is determined on an individual basis, meaning you would need to calculate this for each problem you do. In the middle of the screen, I've attached a graph showing the loss coefficients for various elbows, bends, T's, and valves. This graph is very useful when working out problems in fluid mechanics. Using the information we've learned thus far, we can now try an example problem to find the total head loss of a system. As you can see in the image, we have a piping system which has 4 threaded 90-degree elbows, a wide open globe valve, and a nozzle with a loss coefficient of 2 based on the pipe velocity. The image also gives us a flow rate, Q, which is 12 gallons per minute. Now, before we start calculating head loss, we first need to find the velocity of the system, which is Q over A. As you can see, using the formula on the screen, velocity comes out to be 8.7 feet per second. Now with the velocity, we can start calculating HL major. HL major uses a friction factor of 0.0215, which is found using the Moody chart. Using all the components found in the image on the screen, we find HL major to be 79.62. Now we can start calculating HL minor. As you can see in the formula, HL minor uses the loss coefficient of the system. Using the graph that we showed on the previous screen, we can find the loss coefficient for each threaded 90-degree elbow as well as a wide open globe valve. And don't forget the loss coefficient of 2 for the nozzle is also been given. By adding all these together and multiplying it by V squared over 2G, we find HL minor to be 69.44. Now we can find the total head loss of the system, which is again HL minor plus HL major. Adding 69.44 and 79.62, we get a total head loss of 149.06 feet. I hope you all learned something from this video and can use this in your later endeavors in mechanical engineering and beyond. Thank you.